So we did histograms. I'm expecting you guys did it with your Excel file and did it in your Excel and it working very well, and that's my expectation. Okay, don't lie to me. I know if you haven't done it. No, I don't. Okay. So next step is taking a look at some descriptives, right? So remember the PGA. This is the graphical part, like a histogram like this will tell you the story in a graphical way, but we want to have some analysis as well, right? So now we're going to run descriptive statistics, okay? Here you have kind of the path in Excel, how we're going to do this, and I'm also going to explain what does that mean. Okay, so how to generate all of this information, okay? We go again on the data analysis tab here on data analysis. Again, you have to have the data analysis tools add-ins working in your Excel to make that work. Then you click data analysis and you click descriptive statistics, okay? Then you select the data here. If you select with the first row here, you have to say label in first row. So I selected the label in first row here, select the whole thing. I click here on label first row. I click in summary statistics, confidence level 95%, and confidence levels for the mean as well. We're going to use that. Click OK, and then you have this beautiful chunk of information to use to understand the process, right? And we're going to start with these three things, right? The mean, the median, and the standard deviation, right? So the mean, we know what it is. It's the sum of everything divided by the number of observations. The median, we also know what it is, hopefully. You have 50% of the data more than that, 50% of the data less than that, right? So it's the median point where your data is divided. We know the standard deviation, hopefully from some of your statistics, and we're going to use classes, right? And we're going to use it here a lot of statistics. So Six Sigma is a lot about statistics, as the name already says. Six Sigma, right? You didn't thought it would not be about statistics. So important to say here is the standard deviation will tell you how much of the data is within certain limits, right? If you have a normal distribution, the standard deviation tells you what is the percentage of the data is within those 1, 2, 3 standard deviations from the mean, right? And this, again, we're going to talk a little bit more about that later on, but kind of I put this just for us to remember what does that mean, right? So have this point of inflection here for the first standard deviation, the second one, and the third one here, and it tells you that, you know, one, if it's a normal distribution, 1 plus or minus the standard deviation is about 68% of the observations. 2 plus or minus is 95.4% of your observations, and 3 standard deviations more or less is 99.74% of your observations, right? So these are 3 important things that we can start looking at. Next thing, we're going to look at something called skewness and cordoisis, okay, and it tell you a little bit more about the shape of that distribution. So if the let's start with the skewness. If the skewness is 0, means that is exactly symmetric. So it's exactly a perfect normal distribution. If it's a positive skew, it means that is right skew distributed. So here we have, the positive here. Okay, so it means that you have a kind of a higher slope here, and you have all the skew to the right, right? So that's a right skew distribution. See, it goes a lot less, and it takes a lot more time to go this way. If it's a left skew, it means that here is a lot longer on the left. It's a negative skewness. Okay, and the kurtoisis. So if you go back here, our skewness was negative. Okay. Actually, no, it was a positive, right? The skewness was a positive 27. It means that is skewed a little bit to the right, but 27 is not a big number. So, and if you go back to the data, you can see here, right? So you have more here, and you have a bigger tail on this side here, right? So you can see that is kind of actually skewed to the right. Okay. The other parameter that we're going to look at called kurtoisis. Okay, so yeah, try to practice a little bit how you're going to say that. The kurtoisis, and that's related to the fatness of the tail, right? So if it's a positive kurtoisis, it's a very thin distribution, so thinner than normal. So if it's 0, it's exactly the normal. If it's positive kurtoisis, is a very thin, so a lot more of the observations that are closer here to the mean, a lot less are far away from the mean. And if it's a negative kurtoisis, that's because we have a fat distribution here. So it means that a lot less closer to the mean and a lot more far away from the mean, right? So if you go back here, nope, I'm going the other way, trying to. It's a negative 1.24, and go into our distributions, we can see why, right? Because our distribution is so wide, right? We're looking here, it doesn't even look like a normal distribution. It's very non-normal, and it is very spread out, right? So yeah, that's a good thing. That makes sense what I'm saying. And you can see here, because of the kurtoisis kind of also telling us that story.